Hello and welcome to my tutorial about augmented reality navigation with Vuforia Engine and Unity. Inside Guide is a project of our bachelor thesis, and we received very good feedback on the YouTube channel so far, and there are multiple people that requested for a tutorial, so here we go. Inside Guide has a coverage of 690 square meters. Could have done it bigger, but somehow you have to, keep track of the time. There's a navigation mode, a tour mode, and we even implemented a small AR game. And we had translation in German, French, English, and we also published it on iOS and Android. This tutorial I will cut in 3 pieces, which are like the 3 main challenges to solve when you do navigation, which is mapping, localization, and visualization. In the mapping, we scan the environment and we create point clouds, and we represent the whole building or situation in a data model. In the localization part, we found the position in multiple point clouds, and we do the whole wayfinding to find the fastest route. And in the visualization part, we do an onboarding, because augmented reality is not a very common app use case yet. So this is always nice for the people who are new to this technology to get explained. And the user interface, of course, and showing the path. I remind you, this is in a prototype, so this is by far not nicely solved as we desired, but it works and it looks more or less good for the invested effort. So yeah, you'll see why. And of course, the occlusion is an important part, that people don't walk into walls. And we found out that in usability tests that people really follow the lines that you show. They really stick to it, and if it goes behind the wall, yeah, they just walk into the wall. So like I said in the beginning, the whole app we created in Unity, and we used the NavMesh system of Unity. We actually used the NavMeshComponent system, because the NavMeshComponent is like an extension. You will see why later. And basically, the NavMesh agent is the user. So when the user is walking in the real world, in our digital world, he's walking as the NavMesh agent on the NavMesh. And then other tools are Matterport. This is for creating the point clouds, and Vuforia Engine covers the whole augmented reality part. Let's dive into the first chapter, like the mapping. I will always have like a short explanation part, and then I show some stuff from the Unity editor. In the beginning of our project, we started off with a really simple app to just visualize the point cloud. And the point cloud is a set of data that represents the environment in the real world, of the real world in the digital world. And it basically is all the unique points in the environment that help to orientate the device camera. And in the Vuforia world, this point cloud is called Vuforia Area Target, or just Area Target. And so most of the time I will talk of the Area Target, and sometimes maybe also point cloud, but most of the time area target, because this is like the specific optimized point cloud. You'll see this in a minute. So we used Matterport to store and generate this point cloud. We use this camera that we saw a few slides ago, and there as a result you generate a raw point cloud with all those points, which is really big, and you have 360 panoramas as well, which you can use for other use cases. Then with the Vuforia Area Target Generator, which is a desktop app, you create a Vuforia Area Target, and this is a optimized point cloud, so it's reduced to the points in the environment that are necessary or that are useful for identifying the position of the camera. Because, for example, a whole wall is not very useful, but especially the edges and maybe texture on the wall, pictures or etc. But so it reduces the size of the point cloud to the useful points for the localization. Then it also generates a mesh for occlusion. You will see this later in the tutorial, and there's also texture for debugging. So you have a world like this in the Unity editor. You see this is very helpful to do the debugging and to so you don't have to go there where you want to apply or deploy your app. You can just run it in your editor and do it from home, for example. Yeah, there are two ways to create area targets, or there are two possibilities, but you can use, of course, different cameras, other cameras, newer cameras, for example, like from Leica. We use the Matterport Pro2 3D camera, and we also use the other method you see in a minute. Just explained that we upload it to the Matterport cloud, and then over API it is downloaded to Vuforia Area Target Generator. In the Matterport API you have to purchase the Matter pack, which contains the point cloud. I think it's $43 or something. And then from there you can import it into Unity. I won't cover this whole process in this tutorial because there are very good guides and tools from Matterport and from Vuforia on their websites to help you do this, and this would make this tutorial much bigger, but we just stick to those recommendations there, and this worked very well for us. But feel free also to ask about this stuff in the comments. Then the other way of creating area targets is the Vuforia Area Target app. We also did this. I'll show you a comparison, and then yeah, we used those in the app. We used actually both in the app to have a side-by-side comparison. The pros and the cons from the different methods. With the camera we have 360 panoramas, we have a really good mesh which is also good for VR application, and you have the point cloud in Matterport, and you can use it for other stuff, for example. It takes about 1 hour for 100 square meters, and then it processes, so the artificial intelligence algorithms of Matterport are calculating all this stuff, the point cloud and the mesh for you, and it takes about 2 to 48 hours. And the max size for Matterport, they say it's around 450 square meters to 900 square meters per scan. This is very nice because it's quite big. It's about it usually is about one walkable, one floor of one walk. It's really nice because it's about one floor of a big building of the walkable area. This size. It depends, of course, of the detail, but yeah. And when I say one scan, I mean the combination of the different panorama scans that you do. For those 100 square meters, you probably have to have 50 panorama scans that you go through the building. And then with the Vuforia Area Target generator, it is you can only create an area target, which you can import then from the app on the computer. It has very poor mesh quality, but it only takes 5 minutes because there's the limit. And you can cover around 140 square meters if you don't have too much detail. So I think we did this in a corridor for a test. You have no processing time, it's done right away, and you can just have this one model. Then the results you see here on the left side, we see the camera mesh, the mesh from the camera and the mesh generated from the area target. Yeah, we'll see in the occlusion part later that this you can use this mesh for occlusion, but you can also create your own occlusion objects, of course. But this in the editor, it just doesn't look very nice. Then the positioning of the scans is of course obvious. It should be as accurate as possible to the reality. It makes much more. It makes it easier to organize everything, etc. And also when you walk from one area to the other, it's nice that you always already see the other stuff at the correct position. The data model that we implemented had 4 main classes: building, floor space, and destination. I'll show them right in a minute in the editor. And this is how our points of interest look like. Okay, let's go to the editor. We start right off here in this laboratory. This is from our school laboratory. This was scanned 3-4 years ago, so we were happy to reuse this. Other parts of the building we scanned then during the project, but this scan was already done 3 years ago. It was not very practical that those chairs were here during the scan, but they didn't knew that we were going to use this scan for an augmented reality project later, of course. But yes, it's very hard to remove those because I think they didn't update in the newer Vuforia engine, where the meshes are more separated, but those meshes, they are very random distributed. Maybe I can show it. No, it's not here. Shaded. The shadow mask? No, not the shadow mask. The wireframe. Yeah, the wireframe. Here, it doesn't highlight it. Why doesn't it highlight? I don't know. But yeah, it's just random parts of the objects that are together. So I tried to tweak it a bit, but yeah, I contacted Vuforia as well, and they said it's basically not possible in a normal way. So I'll maybe show you the size of this one scan. This is quite big. I don't remember the exact size. So it's just this floor back to this corridor and this room. And so this is the first scan that we already had. We didn't rescan this because we wanted to save time. Those other scans, this scan was made in with the Area Target app, which you can see here in the back. This one we did with the camera. Yeah, we just have those because then time ran out and we couldn't scan the rough of the building, but of course it would have been possible with Vuforia and the technique we used. But the multiple area targets we'll cover later in another video. So I want to show you a bit how this is set up. Here on the right we have the different things with the area camera, which is basically the user of this, which represents the device camera. We have a capsule collider, rigid body, and we have the default initialization error handler. This is from Unity, and the Vuforia behavior script. It's disabled because we want to enable it by ourselves in the onboarding. We'll cover this later. Yeah, and here as a child we have the NavMesh engine, but we won't cover this now. We'll cover now the mapping part. And so here we have the area targets. It's just a parent, and we just have now one building. For testing, we had also my home. I don't remember why I deleted it, just because it wasn't necessary anymore. I don't remember, but yeah, we also had our home, so we had actually two buildings. And at home I just used it a lot for testing. Oh, I didn't actually want to show this. So, and in the building we have the title, we have the address, we have 2 floors, and we have an image which is used in the UI, and then we have the NavMesh. We ended up using one NavMesh for a whole building, which is much easier to manage than one NavMesh per area target. And then we have the augmentation parent. The augmentation parent holds all the augmentation objects of this app right now. Why? Also because of the same reason of the I just explained before. When an area target is localized somewhere, we want to move everything according to the area target that is localized currently. So then what do we have? We have the floor. Yeah, we have the building. Then we have the ground floor, and in the ground floor we have a floor script, which is the representation, and then we have the floor spaces, and the floor space represents an area target, or the space of an area target. So here in the first floor we have, or in the basement, not the basement, in the floor 0, what's it called in English? We have 2 spaces separated in 2 area targets, which is this one, and I think it stops here, and then this one. And so exactly, and we have here those area target behavior scripts. Okay, this is basically the basic setup. And then in the augmentations, for example, if you start with the living lab augmentation, this is the living lab, the biggest scan. We have the pin, this pin. Well, this is moved always to the destination, so it doesn't matter where it is. It's just in this augmentation now. Then we have those different destinations. Exactly, you see it on the right. You have the translation key. We have the what is this event? Ah, this event is for changing changing the translation. When you want to implement multiple languages, this is very complicated to set up with those keys. But then well, that's how we did it. That we have the key of the title, the key of the information. This is not shown nice because of the rendering of those. But then in the game, it looks totally fine. It's just in the editor. It doesn't look nice. Why it looks now nice? I don't know. Interesting. Okay. So other parts of this destination object is the goal. The goal we call just the box collider of this destination. So if the user walks in here, it realizes, okay, we arrived at the end. This is not very nice that it's going actually through the floor, but we just didn't have time to really fine-tune this stuff. Yeah, you can make this of course smaller. It doesn't have to go through this to the floor, especially if one is up here. You could end up arriving in the wrong destination. Anyways, yeah, I think this is all set up in a prefab, which is somewhere here, which we could improve, but I think we'll just look at the rest. We have the goal, we have the sign of course, and we have the destination details. Those are, what are those? Ah, this is the UI. This is references to the UI controllers. Okay, and the other controls that are necessary for the navigation. We just stick those in here, which is not very nice, but that's just how we did it. You could solve this different, of course. You cannot make it public and then, yeah. Anyways, yeah. So this is basically how this is set up from the data model view, and then we have here also the Easter egg. So if you click on here, you activate it. I can show this later. Let me now show the editor, how it looks like. So in our project, we wanted that the AR camera is only activated after the onboarding. It was quite a hard work to do, but maybe I can also show it in a separate video if this is desired, because you want to ask for the user's permission not right in the beginning. We wanted to ask it during the onboarding, but this is why I cannot just start in the normal. When you start off with the Area Target project, you can just start with the scene. In our scene, we have to activate the correct area target. Where is it? Here, ground floor, living lab. Oh, it's already. Oh no, it's not there. Activated. So, and we found out the bug of area target behavior script, that when you have multiple, maybe they solved it in 9.88, I don't know, but when we had multiple area targets enabled at a time, then it crashed. It did crash, or it just didn't load the air camera. So this might be fixed, but yeah, we can also try it out later. Okay, for now we just hit this button here, and then we see how it works. So this is the start screen. You have the you can even look at it again if you watched it already once. It explains a bit how it works. It asks for the allowance. Here it's automatically accepted. This is why it continues, and then it explains how the navigation is done. And then here we come to the main dashboard. Here you can choose between three modes. We choose the navigation mode. Here you can choose the different destinations. These are just the same information as we saw before in those augmentations, and those different destinations just represented here in 2D. Here we can also click on information. Here you can even listen to, here's even one of our professors who explains this this place. Exactly, so maybe we want to navigate to some place. So with the right hand move I can move around here. This you will see only in the editor. Of course, all of this mesh you won't see in when I will be walking with the tablet in my hand through the reality. And this is a manually added occlusion. I will explain it later, but this is just a bit disturbing, but it's, yeah, I didn't find another way. When you arrive, there's a message that's shown. Here you can also tab, and I see this information again. This was maybe a bit too close. Let's choose another one, maybe Brennman's Coffee. So if I go there, I see this arrow, I see this path. It updates always when I walk. It updates around the corner. And when I don't see the line, I see this flash that is showing basically to the next arrow. So if I walk, I also see the meters here, calculation of the remaining meters. And if I arrive, I see this information. I also see those in the air. If I walk around, I see this boards in the air. And then we'll save the Easter egg for another time. Okay. Here we just have a button also to show the nav mesh. This is really nice. When you walk around, you just see where is a place where it's calculated. This is of course not very useful for the user. It can be useful for the user if it's done nicely on the side maybe of the walls, etc., or it can be like the guiding lines, I don't know. But it may be also just be nice for you as a developer to have some sort of knowledge, visual reference, where is your nav mesh. This has been really useful in the development. Okay, I hope this helps you a bit to get started with this project, that you have a bit of an overview, what is necessary, how it works, and yeah, let me know in the comments how you understand the different things. If you have problems, comments, if you have solved it differently, if you found out something, or you have any ideas. It will be much appreciated to share it with me, and with of course when you comment something, it's also other people can profit from your ideas. And yeah, that was it. See you next time.